Okay, so this is chapter 25. Homework. Gave the direction of the missing quantity for each of the four electromagnetic wave listed in the table. Okay, so here is the first one is direction of propagation. So basically the direction of V, direction of E, direction of the B. So for this kind of problem, all right, so you follow this rule. So E, B, V, right? Right hand. Okay, so know two of them, you figure third one, but you have to follow this sequence. All right, so this is V is, so first one, V is X. Okay, so this is X, Y, Z, X, Y, Z. So V is X, first one, right? And E is B, V, E. E is Y, right? Okay, all right. So you see, you know V, you know E, figure out B. So right hand rule, point to V, curve to E, that's a B. So B will be positive Z. Second one, V is X, right? We don't know B, we don't know E. We know B is Y, second one. Now it's second one, right? So this is a B. Okay, looking for, wait. B is, okay, B is Y, right? Looking for E, all right? Looking for E, how to figure out E? B, V, E, okay? So B, the first one. B cross V is your E, right? B is Y. And then point to B, curve to V, then that is negative Z, okay? All right, third one. One by one, right? Third one, so let's make this, right? Third one is V is negative Y, so this is, oh my God. So V is, so this is X, Y, Z. V is negative Y, so this is V, all right? Direction for E, E is positive Z, this is E. Okay, find B, right? So find B, and then how to find B? V cross E. V first, V cross E, right? Point V, switch to E, then this is negative X. All right, D is, last one is E, we know E, E is Z. So this is E, right? So, and we know B, B is Y, so this is B, X, Y, Z, right? B is Y, and then we figure out looking for V, E, so this is E cross B, you see? Find this one is E cross B, right? So point to E first, then sweep to B. And so this one is negative X, okay? All right, so that's the first question. Second one, when an airplane communicates with a satellite using a frequency of this, right? Okay, so we know F naught equal to 1.535 times 10 to the power of 9. This is the frequency. The signal received by the satellite is shifted by 207. Okay, so first, the signal received by satellite equal to shift the high by 7, right? Higher means more frequency, 1 plus U over C F naught. Okay, so from this equation, we can figure out F prime minus F naught equal to U over C F naught. So basically, you times out, right? Okay, so this is a shift higher. So this equal to 207 Hz, right? Okay, so is the airplane moving towards or away from the satellite? Well, towards, because you gain higher frequency. What is the components of the airplane's velocity towards or away from the satellite? Okay, so basically ask you about the velocity, right? So I'm looking for the u. All right, so from this equation, right? So we know 207 equal to u over 3 times 10 to the power 8, right? And then f naught, we know f naught. This is 1.535 times 10 to the power 9. Okay, just one equation, one unknown, right? So we can solve for u, you see, times this divided by that. Okay, you got it. Next one. How fast would a motorist have to travel for a yellow? So yellow, lambda equal to, it's yellow, right? Traffic light to appear green. Okay, so green will be, so this is lambda 0, right? And prime equal to green 550 nanometer. Let me see if this is 550. Oh yes, 550. Okay. Okay. How fast, right? Hey, how fast? Okay, so how fast, right? So how to use the equation? We know f prime, right, equal to f naught 1 plus or minus, doesn't matter, right? So let's see, assume this is, we don't know, right? Plus or minus uc. Okay, so that's the equation. So what is your, this one? Wavelength, right? So wavelength equal to c over this one. Okay, so speed over frequency, right? So equal to speed over f naught 1 plus minus. Let's just do this way. So let's just substitute both, right? Okay, so we do this. We do, what is the frequency? So frequency equal to c over lambda prime. What is frequency, right? So this one is c over naught 1 plus minus uc. You see, because this guy is shorter than this guy, which means frequency will be bigger. Okay, so f prime will be bigger than f naught because lambda prime is smaller than lambda naught. Okay, so frequency will be higher. So higher means you have used a positive sign, positive, right? So you just drop the negative sign because the higher frequency is higher. So c over lambda prime equal to c lambda naught 1 minus u over c. See that? Okay, so you know this number, right? You know lambda prime, you know lambda, you know c, you see? You know, see here, figure out you see u, solve for u. This is one equation, one unknown, you can solve for u. Okay, so whatever you hear is this. And should the motorcycle be traveling towards or away from the traffic light? Towards. Towards means bigger frequency, okay? All right, so that's this problem. Next one. Which color of light has the higher frequency, red or violet? Okay, you know, from the full spectrum, you know, right? So high frequency, high wavelengths, red, violet frequency, violet. Okay, so frequency, right? So this is visible. This is your violet. This is your red. Okay, high frequency. calculate the frequency of blue light with the wavelength of this, right? So if you know wavelength, frequency equal to C over wavelength, right? Equal to 3 times 10 to the power of 8 divided by 470 nanometer, 10 to the power of -9. Okay, so you have a big number here. Calculate the frequency of red light with the wavelength of this. Okay, same idea. Okay, so just put a wavelength here. All right, next one. Television is tuned to a station broadcasting at a frequency. Okay, so it's a frequency. For best reception, the rapid ear antenna used by the TV should be adjusted to have a tip-to-tip length equal to half a wavelength of the broadcast signal. Find the optimal length of the antenna. Okay, so should have just to have a tip-to-tip length equal to half. Okay, so L equal to half over wavelength, right? Okay, so looking for L. And before you know L, you have to know what's the wavelength. Wavelength equal to C over F naught. Okay, so this is equal to 1 meter something, right? 1 point something. Because this is cancelled, right? So 1 point something, 1.5, about 1.5. That's a lambda. Actually, it's a little bit less than 1.5. And then half of that. So L equal to half of the wavelength. Okay, so half of that. All right. Number 6. The magnetic field in an electromagnetic wave has a peak value, B peak value, 2.9 micron Tesla. For this wave, find the peak electric field. Okay, so we know peak electric field equal to BC. That's what we learned from class, right? Electric field and magnetic field linked by this equation. Actually, this equation applies for any value. Instant value, peak value, right? EMF value, they all holds. So this is peak value. The peak intensity, right, equal to, if you know magnetic field, equal to B square over mu naught times C. Yeah, that's the intensity, right? Okay, so plug in this equation, the peak intensity. So intensity is this one. You bring intensity of the magnetic field here, then you get the peak intensity. The peak intensity. Okay, so maximum intensity. The average intensity. Average intensity equal to root mean square of that one, mu naught C, right? What is root mean square of this? Root mean square equal to peak divided by square root 2. Okay, so you see you have peak here. This is peak. And then this is your root mean square divided by square root 2. That's your root mean square value. Okay, so plug in. Next one. At what distance will a 45 watt, so we know power equal to 45 watt, have the same apparent brightness as P1, P2 equal to 120 watt, viewed from a distance, R2 equal to 25 meter. Okay, so basically you have a light bulb, right? So P1, and then at a certain distance, R1, right? And you have a P2. This distance is 25, R2. Okay, they have the same intensity. So first, what's the intensity? Intensity equal to power over, actually intensity is E over T times A, right? So E over T is P. What is A? Well, intensity here is shared by the whole surface of the sphere, 4 pi R1, okay, R1. So we know I1 equal to P1 4 pi R1 squared, squared, okay? I2 equal to P2 4 pi R2 squared, right? Okay, so if you make them same, okay, so P1 R1 squared equal to P2 R2 squared. So you're looking for R1 value, right? So how far? Okay, so R1 square equal to R2 square, P2, P1, you do square root. Okay, so plug in, that's the value. Okay, so next one. All right, next one is number 8. After filtering through the atmosphere, the sun's radiation illustrates Earth's surface with an average intensity of this. Okay, so average intensity is 1.0 kilowatt meter square. Okay, oh, very intensive. Assume this radiation strikes the 15 meter by 15 meter black flat roof of a building. So A equal to 15 meter times 45 meter, right? So that's area. At a normal incident, calculate the average force the radiation exerts on the roof. Okay, so force. All right, so looking for force, average force. Okay, this is average, right? Well, what's a force? Force equal to dp dt, right? So this is a momentum. I'm sorry, delta p over delta t, right? In class, we know momentum equal to E over C, right? So this is delta E over C delta T. Okay, so this is delta E over delta T, then time divided by C. Okay, delta E over delta T is power. Okay, so this is momentum, is power, right? Over C. What's the power? Power is, what's the power? Power is intensity times area, right? So just keep that in mind. So intensity equal to E over T times A, right? Equal to power over A. That's intensity. So power equal to intensity times A divided by C, right? All right. So intensity. So average force equal to average intensity. So average force equal to average intensity times area divided by C. Okay, so that will be the answer. Plug in. Number 9. Find the root mean square electric and magnetic field at a point. Okay, root mean square. Root mean square. Electric field. Okay, so 2.5 R equal to 2.50 meter from a light bulb that radiates. Okay, so we know power equal to 115 watt of light uniformly in all directions. Okay, so well, actually this is pretty straightforward, right? So intensity, first intensity, right? Intensity equal to P over 4 pi R square. Okay, that's intensity. Right, and the intensity, also we know intensity equal to this intensity, right? So power intensity equal to let me derive a little bit, which means U, right, equal to electric field. So this is epsilon naught E squared, right? So that's a U. And then intensity equal to U. So in class we talk about this. So this is area, this is CT. Intensity equal to energy, right? Over area over time, right? So energy here is U CTA, right? So the volume. Okay, so divide by AT, cancel, right? So equal to UC, and U equal to this, right? So equal to epsilon naught E squared C. So that's the intensity. So we know intensity, but this intensity actually is it's average intensity. Okay, so average intensity, because the power here is average power. It's a root mean square power, average power. So intensity equal to epsilon naught E squared C. So this is average. This got to be root mean square. If we use average intensity here, then whatever value here is root mean square of electric field. Okay, so I average equal to epsilon naught E root mean square C. Okay, then you can figure out what is the root mean square of the electric field. All right. Okay, last one. Unpolarized light passing through two polarizer whose transmission axes are at an angle of 30 with respect to each other. Okay, so here is unpolarized, right? So unpolarized. This is called unpolarized, right? So you have one polarizer, okay, and another. Let's see. Let me make it this way. So let's make this one, right? So this one and this one. Okay, so assume this whatever angle here, right? Whatever angle here. So that's a P1, P2, 30 degree difference. Okay, so this is 30 degree. 30 degree, those two polarizers have a 30 degree difference. With respect to each other, what fraction of the incident light is transmitted through the polarizer? Okay, so about what's here. So this is I naught. Okay, passing through one polarizer will be this, right? So intensity will be half. Okay, and then you have passing through another one. Okay, so then you look at the angle between them. So now intensity passing through here equal to whatever intensity of this light, then times cosine 30 squared, because they have 30 degree, right? So this is intensity, final intensity. Okay. Cosine 30 squared. Cosine 30 is the square root of 2 over 3 squared half naught, right? So what is this? 4, 3, 3/8. 3/8 of the power passing through. Okay. All right. So that'd be all. Yeah. Okay.